this is the first video of a new series, Data Science Tech Interview Questions. And this is the first module, Probability. And in today's video, we will review conditional probability and related interview questions. Let's first take a look at the question. A couple has two children. You discover that one of their children is a boy. What is the probability that the other child is also a boy? So let's first review what is conditional probability and then come back to solve this problem. Before I talk about conditional probability, let's first define a random experiment, rolling a fire die of 6 faces. In this random experiment, the sample space S has 6 elements. 1, 2, 3, 4, 5, and 6. And all the outcomes are equally likely to occur. So probability of 1 is equal to 1/6, and 2 is equal to 1/6, etc. Now let's consider an event C, which is rolling an even number. Then we can write it in a set notation. So it should be 2, 4, or 6. Now let's consider another event A. The event A is rolling a multiple of 3. Then A should contain 3 and 6. Now let's first calculate the marginal probability of C and A. Probability of C should be equal to the number of elements in C divided by the number of elements in the sample space. So it should be 3/6, or 1/2. So this is called the marginal probability, or just the probability. Similarly, probability of A is equal to the number of elements in A divided by the number of elements in S. So it's 1/3. Again, this is the marginal probability of A. Now let's consider the probability of A given C. So that means we know that the number is an even number. Then what is the probability that it is also a multiple of 3? So this is the conditional probability. So let's first just use the Venn diagram to answer this question. Let's draw a Venn diagram. This rectangular area represents the sample space. And we have event C and event A. If we observe these two events, 6 is in both of them. So 6 should be in the intersection of these two events. Then C also has 2 and 4, and A also has 3. And 1 and 5 are outside of A and C. So this is a Venn diagram. So now let's try to calculate probability of A given C. Now we know that C has already occurred. So there are 3 numbers in C, which are 2, 4, and 6. So 3 elements in C. What is the probability that A also occurs? A occurs when we roll a 3 or 6, but only 6 is also in C, which is in the intersection of A and C. So there's only 1 element in the intersection. So in other words, given that C occurs, the probability that A also occurs is 1 divided by 3, because there is only 1 element in the intersection. And if we use a Venn diagram to show the probability, it should be something like this. The numerator should be the intersection of A and C, and the denominator should be C itself, because we know that C already occurs. So this is the conditional property of A given C. Then let's use a Venn diagram to show the probability of A, the marginal probability, which is also 1/3. Okay? Let's just use 2/6. So it should be somehow like this. The numerator should be A, and the denominator should be the entire sample space. So the conditional probability of A given C is the updated probability of A occurs, provided that C already occurs. Originally, we have a ratio like this. Okay, so now we have a ratio like this. So now let's review the definition of conditional probability. The conditional probability of A given C is equal to probability of A and C divided by probability of C. So the numerator is the probability of the intersection of A and C, and the denominator is probability of the condition C. So in this formula, A is the event of interest, and C is the condition event. So A and C have different roles, and the denominator should be probability of the condition always. All right. Now let's go back to answer our question. So a couple have two children, and we discovered that one of them is a boy. What is the probability that the other child is also a boy? At the first glance, you might think it should be 1/2 because the sex of children is independent. So knowing the sex of one child should not have any influence on the sex distribution of another child. However, let's see if we follow the conditional probability formula, what it should be. So let's first define a sample space. There are two children, so four possibilities. Boy, 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 girl, girl, boy, and girl, girl. Then let's define the condition event, C. So C is one of their children is a boy. So at least one of them is a boy. So C has three elements. Okay, so only this event does not satisfy this condition. And our event of interest A is the other child is also a boy. So it's the BB case. Then let's follow the formula of conditional probability to calculate P of A given C. It should be P of A and C divided by P of C. And because A is a subset of C, A belongs to C, so the intersection is just A itself. P of A is just 1/4. P of C is 3/4. So the probability is 1/3. So now let's use a Venn diagram to solve it directly, visually. Let's draw a Venn diagram. So this is the sample space. Let's first draw C. C has three elements, BB, BG, and GB. Right. And BB itself is event A, actually. So given that C occurs, so C is the whole circle. Okay. What is the probability that A also occur? So that's why P of A given C is equal to 1 divided by 3, because C has three elements and A only has one and it is contained in C. So 1 divided by 3 is the answer. Now let's take a look at another question, a challenge question from Uber. A fire coin is tossed twice, and you are asked to decide whether it is more likely that two heads showed up, given that either A, at least one toss was head, or B, the second toss was a head. And lastly, does your answer change if you are told that the coin is on fire? If you want to answer this question by yourself first, you can pause the video and work on it and then resume the video. I'm going to solve the problem with you for now. Now let's first define the event. So of course the sample space has four elements. Head, 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 tail, tail, head, and tail, tail. Because a fair coin is tossed twice only. And now let's define the event of interest A, which is two heads, having two heads, so HH. Now consider the two scenarios or two conditions. The first one is at least one toss was had. Then C1 has 3 elements. C2 is the second toss was a head. So only 2 cases. Then it's very simple to solve this conditional probability without even using the formula, right? We can just use our common sense. P of A given C1 should be 1 over 3. Because C1 occurs, C1 has 3 elements and A is in it. So P of A given C1 is 1/3. Similarly, P of A given C2 is 1/2. And the last question is, does your answer change if you are told that the coin is unfair? Because you see, C1 is always larger than C2. Consequently, P of A given C1 is always smaller than P of A given C2. So it doesn't matter the coin is unfair or not. Probability of A given C1 is always smaller than P of A given C2. Alright, that's all for this video. In the next video, we will review the concept of Bayes' theorem or Bayes' rule. And we will also talk about a few interview questions about Bayes' rule. Thanks for watching. See you next time.